We're going to take a look at writing or listing the domain and range for different functions. We're going to start with something you're probably familiar with. Here's a nice old table, and you know that we call this XY, but we could call this input and then output. And of course, we could call this the domain, and we could call this the range. So in a case like this table, if you were asked to write the domain, you would just list out all the values in the X or the input column. And if you were asked to write the range, you would write all the values in the Y or the output column. And writing that domain and range is pretty darn easy. Now, the difference of what we're going to do today is we're going to move from data like this, which is discrete data, meaning we go from a -4 to another integer -3 to another integer -2. And we're going to move to graphing data, which is going to be continuous. So let's begin with the problem that looks like this. Okay, we want to write the domain and the range for that function. And part of the problem is I can't just list integers because you can tell that there's spots on that graph between the integers. For example, this is x equals -3. I'm going to put a dot at x equals -2, but there's plenty of little dots in between there. So we have continuous data, so our old method of just listing is not going to work because we're going to miss all those pieces in between the integers. So to begin with on this first one, I'm just going to write down the answer and then we're going to explain how I got to that. So here's my answer for the domain. And what this is saying in English is my x values on the graph that I'm looking at range between the smallest x value of -3 and the largest x value of 6. Or x has to be bigger than -3 and x has to be smaller than 6. Well, if I trace my pen along this graph, at this point I'm at an x value of -3. But as I move to the right, I go along and I get bigger x values. So for example, right here, I'm at an x value of 2. I'm not quite sure what my y value is. I'll just say it's 4. It may not be 4. Okay. But as I move along this graph, I move from an x value of -3. And when I end, my x location is 6. So what I just wrote in math language is I went from the smallest possible x value to the largest possible x value. In fact, that's what you should use to guide yourself anytime you write the domain in this way, which I realize can be awkward. Always put the x in the center and just choose the smallest possible x value to go on the left and the largest possible x value to go on the right. That's all you do, but for some reason that ends up being pretty awkward. You're going to follow the same thinking for the range. So the range, which is the y values, I want to put the y in the center and say what's the smallest possible y value on my graph and what's the largest possible y value on my graph. So in a case like I'm looking at here, my smallest y value is 0. That's my lowest altitude I get. And when I'm all done, I got to a height or a y value of 5. So I put y in the center. And I say the very smallest y value is 0, and the very largest y value is 5. In other words, my y values ranged from 0 to 5. 0 the smallest, 5 the largest y value. And I encountered every other y value in between. Okay, I know that's pretty awkward, and it takes some getting used to in practice, and we'll have plenty of practice in class. So let's take a look at this graph. This arrow means this graph goes on forever and ever and ever in that direction. So if I'm thinking of my domain, the first thing I'm going to put on my paper is the x right in the center. And then I have to think, what's the smallest x value possible? That's going to go there. What's the largest x value possible? That's going to go there. Well, as I look at this graph, it begins over here at an x value of -3. And there's no x values to the left or smaller than that. So -3 is my smallest one. And then as my graph keeps going, and going and going. It goes forever in that direction. That means we're going to go forever along the x-axis. That means we're heading to infinity because there was no ending point like I had in the previous example. So x falls somewhere between the smallest x value and the largest x value. And so now I just need to put in the proper symbolism. And by the way, when you're going to infinity, you can never equal infinity, so I don't put the little equal sign underneath there. We can equal a -3, so I do put the equal sign underneath there. All right, I'm taking a look at the same graph, and now I'm thinking about the range. So the very first thing I would put on my paper is the y value. Then I would have to ask myself, what's the smallest y value possible? Well, your eyeballs might want to look at the beginning of the graph, but that's not the case in this case. My y value when I start is 1, but then my graph dips down to its lowest point, its minimum, its absolute minimum in this case, and then ends up going back upward forever and ever and ever. So that point right there, 0, -2, tells me the smallest y value my graph will encounter is -2. And since it's going to go upward forever and ever and ever, it's heading to infinity. So this is math language for what are all the possible x and y values of that graph. Every time I'm writing the domain and the range, I just realize that the x or the y goes in the center, and I think about what's the smallest x value possible on that graph and what's the largest x value possible on that graph. What's the smallest y value possible on that graph? What's the largest y value possible on the graph? It's as simple as that, even though students definitely believe this is an awkward task. Okay, I'm going to end with these last two, and they look pretty similar, except this one goes on forever in both directions. This one has an endpoint and goes on forever in this direction. So if I were asked for the domain, first thing I do is I put the x in the center, and I look at this graph. What's the smallest x value, I'm thinking of the smallest one, that this graph could achieve? Well, since the graph goes on forever and ever and ever in this direction, the x values continue to get more negative and more negative and more negative. So I'm going to call this -infinity. And as I look at the largest x value that this could ever have, this is kind of an endpoint. It is an endpoint. It's an endpoint for the graph at x equals 4. That means x can't get any larger than 4. So now I just put in my symbols. X has to be less than or equal to 4, but x has to be greater than -infinity. Or in other words, smallest x value, largest x value. Moving on to the range, y is the range, and the biggest y value I have on this graph is a 2. This graph goes downhill forever and ever and ever. So it's going to head to -infinity, and now I have my domain and my range. Now if I use this graph but make one small change, which is instead of stopping at that point, it goes on forever, now I have kind of a unique dilemma. The domain is standing for the x values, and basically since my graph goes on forever in this direction and forever in the other direction, it's going to -infinity on the left and +infinity on the right. Basically, every single x value in the world would show up on that graph. If I think about the range, my graph continues to go upward forever and ever and ever, but my graph also continues to go downward forever and ever and ever. So that means it can get as low as -infinity, and it can get as high as +infinity. So this is pretty awkward when you don't have any ending spots, but you're still saying what's the smallest and what's the largest. What's the smallest and what's the largest. By the way, sometimes in the math world, since that covers every single number possible from -infinity to +infinity, you will sometimes see this, all real numbers. Somebody could write that, and that's just as good as writing that. Same thing here. You could say all real numbers, and that would be just as good as writing that. So no matter how awkward the graphs get, remember that what you care about is domain and range, smallest to largest, smallest to largest. And then you'll be able to list the domain and the range for your function.